In 2026, researchers reported something that sounds impossible. Adult mouse brain tissue linked to memory recovered electrical function after being cooled into a glass-like state and rewarmed. The race to defeat death is no longer only science fiction. Silicon Valley has started treating aging less like an unavoidable law of nature and more like a technical problem. And there are now 3 possible escape routes. Repair the body faster than it deteriorates, pause the brain until further medicine can recover it, or create a digital version of the mind that continues after the biological person is gone. Each path is radically different. Each has enormous problems. And if one succeeds, the first people to access it properly will not be ordinary people. Aging is not controlled by one switch. Researchers describe a network of biological problems: damage to DNA, changes in how genes are regulated, dysfunctional mitochondria, exhausted stem cells, chronic inflammation, and cells that stop functioning properly but refuse to die. The important shift is that scientists can now name many of these mechanisms, and once something can be measured, engineers begin searching for a way to change it. Altos Labs says its mission is to restore cell health and resilience through cellular rejuvenation. Retro Biosciences is even more direct. It wants to add 10 healthy years to human life. Peter Thiel has funded anti-aging research for roughly 2 decades. Sam Altman reportedly committed $180 million to launch Retro. Retro says its first experimental drug, RTR-242, entered a phase 1 clinical trial. The drug is designed to restart autophagy, the cellular cleanup system that removes damaged material. That does not mean an anti-aging pill has been proven to work. A phase 1 trial is an early test, primarily used to examine safety and how a drug behaves in the human body. But the field has crossed an important line. Ideas that once lived in futurist books are entering laboratories and early human testing. Their investments are not proof that immortality will work. They are proof that extremely powerful people believe the possibility is worth a serious bet. The second path does not attempt to cure death today. It attempts to preserve enough information for a future civilization to try. Traditional freezing forms ice crystals, which can tear apart cells. Vitrification takes a different approach. With specialized chemicals and rapid cooling, tissue enters a glass-like state without forming the same destructive ice structures. In 2023, researchers vitrified rat kidneys, stored them for as long as 100 days, rewarmed them with nanoparticles in magnetic fields, and successfully transplanted them. The organs restored life-sustaining kidney function in the recipients. Then came the 2026 brain tissue result. Researchers reported short-term functional recovery in the adult mouse hippocampus after cryopreservation by vitrification. That is remarkable, but it is not resurrection. A slice of mouse brain tissue is not a human mind. Electrical activity is not proof that memories, personality, or consciousness survived. No cryonically preserved human has ever been revived. But one of the assumptions surrounding cryonic preservation, that adult brain tissue is simply too fragile to survive, became harder to dismiss. Then, only months later, a longevity company backed by some of Silicon Valley's most powerful money announced new financing at a valuation of $1.8 billion. Cryonics remains a wager on technology that does not exist. Preserve the structure today and trust that future medicine will understand how to repair and restart it. The gamble is not only whether the body can be repaired. It is whether the information that made the person unique is still there. The third path may arrive first, and it may also be the most deceptive. Artificial intelligence can already imitate a person's voice, appearance, and writing style. Feed a system enough messages, photographs, recordings, and videos, and it can produce a convincing digital character. Researchers call some of these systems digital ghosts, interactive simulations of people who are dead. But imitation is not mind uploading. A true whole brain emulation would require scanning the brain at extraordinary detail, understanding how its physical structure, electrical activity, in chemistry produce thought and then recreating those processes inside a computer. We do not currently know how to do that. We do not even know whether a perfect digital copy would preserve consciousness. Imagine a machine creates a copy of you that remembers your childhood, recognizes your family, and insists that it is you. Are you still standing beside it? If your biology body dies, did you continue?